All right, so this video is about writing these polynomials as a linear pair of factors and then also factoring, so it's an extension of our factoring. So what you're going to write is a polynomial, b of x. This is what we have here. And we want to make this polynomial a factored form. So if we say we want to find a polynomial of lowest degree with zeros of -7, multiplicity of 3, and 2, it's the same thing we did before. So this would be x plus 7, change the sign, multiplicity of 3, and then also 2 is a 0. And so now we have written this as a linear pair of factors of lowest degree. That's all we're doing is writing it in the factored form. Okay, so if we're going to use this one, we do the same thing we did before, and that's to find a 0 and then use synthetic division on it. So we're going to plug this in our calculator and find a 0. So we plug it in our calculator. We hit zoom 6 to graph it in that standard window, and we're looking for just a 0. If we can find 1 0, we're good. Okay, so it looks like -2, 1, and 3. Let's just test 1. I like 1, so literally just testing 1. It says 0. So 1 is a 0. We can go back and find everything else. So we know p of 1 is going to give us 0. So if I factor this with 1, divide this by 1, we will be able to factor it. And there we go. So it does make 0, which is what we wanted. And so what we're left with is x squared minus x minus 6. So what this allows us to do is to take our polynomial and now rewrite it. So we know it's x minus 1. That was our 1. So we get x minus 1. And what's left now is that part. So if I multiply this by this, I get this. This is our first 0. And so now all we have to do is take that quadratic and factor it. So we're breaking these down into quadratics just like before so that we can factor them. So whether we're finding zeros or solving an equation, it's the same exact steps. It's just different purposes of it. And so there we go. That is not the correct answer. Plus 2. There we go. That is our factored form. And you can go back to our TI and double check it. So there was the 3, there's the -2, and you can check them, trace -2, hit enter, it's 0. So there it is. So -2 and 3 gives us our fully factored form. So that's all we're doing. You're writing it as a linear pair of factors and factoring it. Okay, so why they're calling it now linear pairs of factors is you also have irrational and imaginary factors. It's not just factor until you can get nice rational zeros. So on this one, we have a degree 4. So if you remember, to get this down to a square, we have to find 2 zeros. So we're going to plug it in our calculator, and we got to find 2 zeros to use. So I've inputted it in our calculator. We hit zoom 6. And again, we're looking for 2 zeros or a 0 with multiplicity, just like before. Okay, so that's not good. That's not good. So they don't look good. So let's just see if they are actually okay. So second calc, intersect number 5 was not what we want. We want zeros, number 2. And we want left and right. And so 1 and 2. So our left bound is 1, right bound is 2. And hit enter and hope that it's nice. And it's 1.4141. That's the square root of 2. So we know that square root of 2 is a 0. So we do 1, -4, 3, 8, and -10. And we hope that this works perfectly and gives us 0 at the end. And if it doesn't, it's not square root of 2. So that's 1 square root of 2. That would give us -4 plus square root of 2. So it's like doing the imaginary. So I'm going to put my little dots here, the complex numbers, and then we're going to multiply again. So that would be square root of 2 times -4 plus radical 2. Be -4 radical 2 plus 2. So we'll put the 2 first, minus 4 radical 2. So it's 5 minus 4 radical 2. And then we do it again. So radical 2 times 5 minus 4 radical 2. So radical 2 is 2, times 4 is 8. And then we do it again. oops, 8 and 8 is 16, right? That was negative 8, there we go, and plus, there we go. So that's 0, and so we get 5 radical 2. So 5 radical 2 times radical 2, it's radical 2 and 2 is 10, and we get 0. So it works perfectly. And if you know that radical 2 is a 0, then since we have a nice rational coefficients, they're not irrational, the other guy has to be, second calc, negative, you guessed it, square root of 2. So value, square root 2, forgot to put the negative in there. There we go, and it should say 0, and it is. So we know that square root of 2 is there with a negative. So, just like the imaginary, you've got to have its conjugate. So we bring down the 1, and then everything will work out perfectly fine and quick this way. Let's cancel, negative 4. The reason we have to get rationals is because we have rationals here. So all the radicals should cancel. So this would then give us plus, so that would be 4 radical 2, and see they cancel again, giving us 5. And then that would be 5 with the negative radical 2, and there's your 0 that we wanted. And so here is our quadratic. X squared minus 4x plus 5 equals 0. And then you would think, oh, it's factorable. But if we look back at our graph, there are no more zeros. And there's no multiplicity going on here, which means these two have to be, guessed it, imaginary. So x squared minus 4x plus 5 equals 0. We're going to use quadratic formula. So that's 4 plus or minus square root negative 4 squared minus 4 is 1 times 5, the negative boy, so on and so on. All right, and then we do the radical. So that's 16 minus 20. See, there it is. That's negative 4. So that's negative 2i. So now when we plug it back in, we get 4 plus or minus. And the negative 2i is not negative 2i. It's just 2i. Remember, scratch it off, put an i. So it's 2i all over 2. And then we divide. So we end up with 2 plus or minus I. So our x's here are just horrible. This is as worse as they possibly get. They're all irrational and complex. But there's your solutions to that equation, right? And so now what we have to do is write them in factored form. So p of x is equal to, and you write x and you change the sign, plus square root of 2 minus square root of 2. And then here you just put the minus sign and you subtract them. So that way if I were to plug in 2 minus I would get 0. And so we get the last one. And now some people will distribute. I like leaving it this way so that you can see, oh, negative 2, positive 2, 2 plus I, 2 minus I. It's telling you the zeros here. So it works out. So this is factored form. So you can see it's the same steps for doing anything here. If it says find the zeros, there you go, radical 2, negative radical 2, 2 plus or minus I. What's the solution to that equation if it equals 0? There they are. What's the factored form? Right there. This is the linear pair factor. Sorry, not the factored form. And that's it. Thank you.